It is now my pleasure to introduce to you, and he doesn't need introduction, but to welcome to the stage Dr. Ian Operman, the New South Wales Chief Data Scientist, who will talk to us once more about new forms of computing. Welcome to the stage, Dr. Ian Operman.
I thought, given the event we're having today, celebrating 70 years of that fateful event here in Sydney, I talk a little bit about the future as seen from the past. I'll talk a little bit about the present as seen from today, and try and give you some clues as to where these data and algorithm issues are coming together, at least with New South Wales Government, and the sorts of things that we're putting in place to ensure that that future is the more utopian type of future than the dystopian future. Let me begin, though, by first of all actually acknowledging the traditional custodians of the land on which we meet today and pay my respects to elders past, present and emerging. Secondly, on the screen is a view of the future in 2050 by a gentleman called Calibut. And there are a couple of aspects about that view of the future. There is tech everywhere, but you don't really see it. It's embedded in everything. There is a rewilding of our smart cities and smart places. And there's a harmonious engagement, if you see it as harmonious, between the modern tech and history built around existing structures. We know that by 2050 we will have another 2 billion people on the planet, but exactly the same amount of land, exactly the same amount of water, exactly the same amount of air. So we have a finite system which we're looking to intensify in a sustainable way. There's also on that first slide the UN Sustainable Development Goals, the world of 2030 as we would like to see it. Outcomes which describe no poverty, life on land, life below water, gender equality, and also there's a goal there on smart cities and smart places. And once upon a time, 2030 was a long time in the future. It's actually now just 8 years away. So if there was a child born today at the same occasion as this 70th anniversary, by the time we hit the UN Sustainable Development Goals, they're 8. By the time they get to the Calibut model or view of the world of 2050, they're 28. Probably had a couple of jobs by then, probably will have had multiple different goes at education, and will almost certainly be operating in a very, very different world than the world today. That's a view of the future as seen from roughly speaking today, 10 years out, 8 years out, 28 years out. And one thing we know for certain is that as human beings, we're actually extremely poor at predicting the future. We have some issues about recognising the past, but we're really rubbish at predicting the future, despite what we try. So I thought, just for a bit of fun, we'd have a look at the future as seen from the past, and what did we think the world would look like as seen through the lens of technology, as seen through the lens of data and data processing, and what are the aspects about our daily lives that we thought the world would look like. Now, I tried to find something from 70 years ago, and that's actually pretty tricky. So I got a view of the world from the 60s that said 40 years in the future, so last decade, so if you allow me a little bit of license here. The future as seen from the 60s was that in home life, we would live in self-cleaning houses, there would be very little housework that needs to be done, there'd be a whole lot of labour-saving devices, and every home would have a home computer, looking pretty much like that. And that says that information technology, that computing, that data processing is really central to the modern life. Every home would have a computer. And earlier this morning we talked about supercomputers in pockets. I'm sure that's the manifestation of a supercomputer as seen from the 60s, jumping forward to the beginning of the 21st century. The view was also, of course, that we'd have driverless cars. They would be everywhere by early 21st century. And yes, we have driverless cars. And there's a real issue which we're trying to face up to now, such as in that image of a family in a driverless vehicle, there's lots of data being processed, there's lots of computing power being deployed, there's lots of artificial intelligence being artificially intelligent. Who's responsible? Who's responsible if people are so distracted with that very exciting game that they have there that they wind up either committing a traffic offence or running into someone or getting into a situation where something really adverse happens? Who's responsible? Is it the family? Is it the father? Is it does anyone need a driver's licence? Is it the car manufacturer? Is it the company that provides the software? Whoever did the last software service? question of who's responsible is one of those big issues that we haven't quite got our heads around when we think about the unintended consequences of technology, and technology which we can actually see today, can actually see deployed today. And it's arguable that autonomous vehicles are much, much, much safer than each and every one of us in terms of drivers. I know every person in this room is an above average driver. I know each and every one of us is better than the average driver. But autonomous vehicles, when you look at the total number of kilometres driven and the number of accidents, is actually a lot better than most of us, or at least those folks outside this room. And then, of course, when we project into the future, there are some other views about having vacations under the sea. That hasn't really happened. There's also references to going to day trips to the moon, but that's starting to happen, kind of, sort of. If you're a billionaire, you can do it, depending on exactly your definition, you can go into space or just below space for a few minutes. And of course, there are some other views about the future of work, the gig economy. This is a view from the 1940s about home deliveries, just-in-time food deliveries, and arguing whether or not they're employees or contractors is probably something which didn't come into that view in 1940s. And of course, even as far back as the 1930s, there were some views about aviation being everywhere, that we would have mobile phones, which were wireless mobile phones, and we'd also have video phones. The view from the 1930s is by now, smoking would be safe, so people could just continue smoking, and they found a way of being able to drink and fly at the same time in a safe way. As mentioned, there are some aspects of predictions of the future which we kind of sort of get right, but there are a whole lot of ethical, societal dimensions which we really, really struggle with when we try and project beyond the immediacy of today, and we start thinking about the likely, the possible, the probable cones of what future uncertainty. And typically, it's issues around, should we do it? Is it the right thing to do? Societal aspects, ethical aspects that we typically don't bake into our thinking about uses of technology. So what have we actually got today? So taking a look at today from the perspective of today, we don't yet have people unambiguously using aircraft. We've got robots. Cutting edge of use of robot is taken from Japan, for example, where you've got an autonomous, intelligent device that can do a fairly narrow range of activities. So it can bring things to your table, can take things away from your table. You could probably pay using some sort of credit card system on the side of the robot. And in general, there are some really interesting aspects about thinking about autonomous intelligent devices augmenting labour, augmenting skills. We're seeing autonomous intelligent devices in agriculture, certainly in manufacturing, in safety, in a whole range of different sorts of areas. And increasingly they're being used to augment what we can do. I think that's kind of cool. And I think that there are a whole lot of good use cases for intelligent autonomous devices. But there's a whole lot of issues that, we need to think about the ecosystem in which these intelligent autonomous devices operate in. So it could be that rather than me trying to communicate to the robot using punch cards or voice recognition, it might be easier if the robot could just access all of my calendars or all my Wi-Fi or Bluetooth-enabled devices to understand who I am, what I'm likely to want, where I need to be next, what sort of time pressure I'm under, and give me a much more personalised service. But there's also issues about whether or not this robot is delivering services to me according to my needs, or it has finite battery, finite time, finite resources, whether or not it's actually optimising what it can deliver to me based on what it needs to do. And then, of course, there's all these other issues about whether or not, if I'm engaging with this device, what's happening to all of my data? What's happening if my data is being used to help train it to do better and more personalised delivery of services for people just like me? There's a question about, am I really consenting to that? What is happening to my data? And there are some other big questions as well. I mean, can you tell it's a robot? Does it matter if you can tell it's a robot? Who's responsible? Who's responsible if something goes wrong? How well qualified is this device that I'm interacting with? And really, what am I consenting to when I engage with this intelligent autonomous device? Now, clearly that's a robot. Clearly it's there to do a very specific little activity. But here's one of my absolute favourites. This is Shudu, and Shudu is an influencer, and Shudu is designed to help you want to wear certain clothes, do certain things, have a certain lifestyle, live the promise of the life that Shudu has. And Shudu's been doing very well. Shudu's been around for a while, has almost 300,000 followers on Instagram, and of course is an avatar. Shudu is designed to make you want this fictitious life that Shudu is projecting but doesn't really have. And so, of course, Shudu's not the only one. There's Lil McQuella, who has around about 2.5 million followers. There's Alexa, there's Siri. All of these are intelligent devices or intelligent algorithms which learn from an interaction with you, which help provide you with better services or find out ways of convincing you to do certain sorts of things, and ultimately also learn about people like me in order to deliver better services. It's an algorithm running on data that I freely provide, and every time I interact with it, I reveal information about who I am, my preferences, where I am, when I am, and potentially also some things about relationships and with me and other people and objects. So we can ask those same questions. Can you tell it's an autonomous device? Does it matter if you can tell? How is it qualified? Who's responsible for what it tells me? And can I trust it? And what's happening to my data, and really what am I consenting to? And of course, something really quite ubiquitous these days, increasingly, are drones, just starting to be regulated in Australia. And they're being used in a whole range of different areas. They're quite cool. You can get great images from them, being used in surveillance, in agriculture, in safety and communications, and are baked into the thinking of 6G mobile communications. And there are some very similar questions that we can ask about drones. If it sits above my house all day in order to provide communications coverage to my neighbour, am I really consenting to that? And if it's not only providing communications capability, but it's also measuring ground temperature for environmental reasons, and it's specific enough to actually measure my body temperature, do I really consent to my body temperature being shared? And if there are two people in my house and you can tell there are two separate people, do I really consent about sharing information about relationships and where I am and when I am? So very, very similar sorts of questions. And the reason for bringing these issues up is very soon I'm going to switch to what we're doing in New South Wales government, specifically when the data meets the algorithm, specifically thinking about appropriate use of AI, and specifically thinking about what do we need to do to understand whether or not the issue that we're looking at, the outcome that we're facing, the goal we're trying to achieve, is actually something we should be doing. It's something which potentially has unintended consequences. Or is it something which actually isn't an AI problem, it isn't even a data problem, it's actually a policy problem or an objective problem. So what are we doing? And I have to tell you, trying to live up to a title of when the data meets the algorithm, knowing that you're going to be between the last presentation and lunch, required me to think a little bit about what are we actually doing. But here we go. You heard Minister Dominello this morning talk about all the great things that New South Wales is doing, digital birth certificates, digital driver's licences, a whole lot of e-planning work. And there are some really, really powerful improvements in efficiency, effectiveness, personalisation, which can be brought to life by just connecting systems together. There's a whole lot more that you can do if you build life journeys as seen across the lens of government, journey of child, family, household, community. Think about better targeted services, thinking about nudging people away from adverse outcomes where possible, and also thinking about application of machine learning and artificial intelligence to try and better understand those journeys, improve the personalisation of services that are delivered, or to do really important things such as sepsis prediction. Your journey as a patient in an emergency department, once upon a time, people would come around the beds, write details down on a glove, and then go back to the computer, type things in, maybe get an alert to say, this patient really has high risk of sepsis. Whereas now, we've got constant monitoring being piloted, constant monitoring of vital signs in the emergency department, and an automatic flagging if you're at risk of sepsis. And there's a very significant set of actions that take place if you alert. We have use of artificial intelligence to identify vulnerable individuals by Revenue New South Wales. When they see signs coming in about someone who's being repeatedly fined, there's a prediction algorithm that says, is this person actually a vulnerable individual? Let's treat them differently. Let's stop fining them and put them through a different pathway. We're also seeing it being used in transport for New South Wales. We're seeing it being used by police. It's being used by education. It's coming up everywhere. And what we have done through the course of last year was establish an AI committee consisting of luminaries, including the immediate past Human Rights Commissioner, Aurélie Jacquet, who leads standards development for artificial intelligence in Australia for Standards Australia, the CTO of Microsoft, and a whole group of other luminaries. Fang Chen is also part of that group. And we're trying to do something really important. Last year we released the AI strategy and policy. 2020 we released the AI strategy and policy. And we've been trying to map between the principles-based policy and the bits. We've been trying to span the gap between where engineers, data people, data scientists, data analysts work, and the principles-based outcomes that we're looking to deliver as government, as overseen by the Ombudsman, as overseen by the Privacy Commissioner, as overseen by the Information Commissioner, as described by the strategy. We're trying to map a pathway between those worlds for all sorts of AI of any description, whether it's operational or not, whether it's alarming, alerting, or acting AI, whether it actually carries out an action. And we've developed an AI assurance framework which tries to map those principles down into what do I do next when I'm building my algorithm or even procuring my algorithm. The principles inside the AI ethics policy, which is part of the strategy, policy, and how-to, there's appropriate use, there's co-design, there's data considerations, there's a whole lot of aspects related to keeping people at the centre, understanding whether what we've got is an algorithm problem, a data problem, or a policy challenge, and ensuring that what we've done is a whole lot of human-in-the-loop conversations. And along the way, we've been looking at trading off some pretty significant tensions. They're not opposites, but they're aspects which we need to consider in order to make this actually a useful framework. We're looking at algorithms, or so looking at the assurance framework, which is complex enough to be useful and yet simple enough to be usable, that it's able to identify risks and think ahead about risks, but also identification of the benefits, and in particular the example of sepsis, the way things are done at the moment and the potential harms associated with that and potential benefits versus the way you might implement it with an artificial intelligent algorithm and the potential benefits and the potential harms. We're looking at the issues of explainable AI. Is it more important to be able to explain it, or is it more important to ensure there's a human in the loop in the event that you can't explain it, but you still have human judgment applied in anticipation of getting more precise and more accurate outcomes? We're looking at the assurance of the use of AI as opposed to the assurance of police activities or health activities or transport activities, ensuring that we're looking at really at health's use of AI as opposed to health itself. And also looking at ensuring human in the loop without falling into the traps of either over or under reliance on AI. And also thinking about ensuring that we have individual responsibility as opposed to loading people up well beyond the level of responsibility they currently have using systems which don't use AI or don't use data. And I'll just come back to that. Is it a policy problem? Is it an AI problem? Or is it a data problem? And this is something that we've tried to build into the assurance framework, and we've tested with multiple different use cases during the course of last year. And there's a couple of simple lenses we've put on this. We think about where we are in the data lifecycle. I'm not going to go into a great deal of detail because I can hear my own stomach rumbling. But we think about where we are in the data lifecycle, how it was created, how it was transmitted, how it was organised and stored and used. And then when we are about to use it, are we authorised to use it? Do we have the right authorising framework? Do we have enough information about the data quality? Do we have enough information about the provenance in order to say, this is how we can use it? These are the types of uses we can make of the data. And then when we've used it, in this case for analysis, what can we do with it? What guidance must we put with this data? What restrictions must we put on these data or data products that are created? The other lens, of course, is it an AI problem? And very often we talk about algorithmic bias and various other things. If we don't get that data part right, then we're really not even going to have a conversation about the AI part. But there's a couple of lenses we put on that. Is it operational AI, something that alarms, alerts, decides and acts, or any part in that chain? Or is it something which we're looking at a historical snapshot of data and we've got a clever algorithm sifting, looking through for insights, and sometimes that's sensitive and sometimes it's not. We're also looking at risks on a spectrum. We're trying to think about, again, through that lens of operational versus not operational, different sorts of harms and how reversible those harms are. If an algorithm decides that you're not going to get through that ticket barrier because your whatever metric you use to get through doesn't match, then that's a harm. You're delayed. Hopefully the doors don't shut on you. But if a human being can come along and just very quickly flip the switch, then that harm is readily reversible with little cost, versus all the way up at the other end of the spectrum where you have critical injury or even death, which results from an autonomous system that's clearly an irreversible harm. And there's many shades of grey between. We also are looking at different risk factors, and definitely not going to go into them now. I'm sure you'd struggle to even read that slide. But there are different risk factors that we're thinking about, which range from those physical injury to psychological injury all the way through to an inconvenience, and thinking about the degree of likelihood. And issues of fairness, issues related to impact on communities of minorities, of people from diverse backgrounds who may not be reflected in the data that you use to train or operate your AI. And what it's resulted in is the New South Wales AI assurance framework that says it's inevitable we're going to use artificial intelligence. In fact, we want to use it. But we are going to spend a reasonable amount of time thinking about all the stuff that we should have thought about before. We'll try and do that up front. We'll try and think about potential harms, secondary harms, harms associated with repeated use or repeated application. We're going to think a lot about data and data quality. And we're not going to say you can't use an algorithm if your data quality is poor, but we are going to say there's a limit on what you should do in terms of relying upon it, in terms of the level of expertise you need to have to access and interpret that data, and also the guidance or even restrictions you should put on data products that are created, whether they're insights or sub-data sets, and then pilot before you scale. And depending on the potential harms, these are the people at the end of your pilot who should be looking at it: internal, arm's length, external with really strict and rigid conditions. The assurance framework was endorsed by New South Wales Cabinet in the middle of December last year. It becomes policy law, air quotes around law, in March, which is next month. And the New South Wales, what was AI Advisory Committee, we offer you advice, you don't have to take it, will become the AI Review Committee. We offer you advice, you'd better take it, we'll have a really good reason why. And that's the intention there, is to make sure that when the data meets the algorithm, that in fact we are thinking forward about some of those consequences. And I'm going to end here. I mentioned at the very beginning that there was a view of the world as seen by James Calibert of the world of 2050, and also of the UN Sustainable Development Goals, which Australia has signed up to, and increasingly people are becoming aware that we've signed up to them. And we've said this is how we want to see the world of the future in 2030. Between the world of 2030 and the world of 2050, there's a big empty space. And if we're thinking about a child born today who's only 8 years old at the end of this decade and is not even 30 by the time we hit 2050, that child is very likely to live to the 22nd century. That child is very likely to live to the world of 2122, which is a number so strange that it's hard to even say. And when we're thinking about an increasingly digitized and increasingly pervasively computed world, an increasing use of artificial intelligence everywhere, in every aspect of our lives, then we need to think about what do we do now to ensure that we keep people at the centre, we keep thinking about the humanity of the application of technologies, including computing and data use and artificial intelligence. And how do we build waymarkers for 2040 and 2050 that say, we want the world to look more like this than the dystopian version of that future world? So with that, I will leave you. Thank you very much for your kind attention, and with the final message that, of course, standards are part of the answer. Thank you very much.